Hello, and today we get our second lesson in Activity 2, which is entitled Radical Expressions. So lesson 2.2, we are going to both write and simplify radical expressions, and we're going to understand what is meant by a rational exponent. So this lesson is actually kind of long, and I don't want it to be, so I'm going to be jumping past the stuff on the first page and getting into more of the meat of the lesson, which is the radical expressions and how we're going to simplify them, and then getting into some rational exponents as well. So we're actually moving on to the second page of the lesson. And what we're going to start with is talking about radical expressions right here. And so, as you're probably familiar with, a radical expression is written in the form the nth root of a, where a is the radicand, and that's the radical symbol, and n is the root index. So, by definition, the nth root of a equals b if b to the n power is equal to a. So we say b is the nth root of a. Now, a little math tip over here says when there's no root index given, assume the 2 is the index. Okay, so like if you just see square root of 36, that is, there's a 2 kind of invisible there. You never really see it written there. So some square roots that you are already familiar with are like the square root of 25 is 5 because 5 times 5 is 25. And so on, 81 is 9, 9 times 9 is 81. And then for variables, x squared would be x because x times x is x squared for all x's that are greater than or equal to 0. And basically that's because we don't want to have any negatives in the square root. We can't take the square root of a negative number. So that's why we have that constraint. So something to also notice is that negative 5 times negative 5, which is negative 5 to the second power, is also 25. So we kind of designate 2 square roots. We've got the principal square root, which is the positive square root value, and we also have the negative square root. So the negative square root of 25 would also be negative 5. So typically we just want the principal square root, but we'll get into some problems where we solve equations and we'll want both of them. All right, so we've got some ways that we can simplify radicals, and I'm going to show you a couple different ways how to do it. The way your textbook explains is they want you to take a radical like the square root of 75, and they want you to find that biggest perfect square you can find in it, like 25. And so root 75 is 25 times 3. Now you can take the square root of 25 and we end up with 5, and we get 5 times the root of 3, and that's your answer. And similar to 72, you'll see 36 times 2, so 6 root 2. But there are other ways to break down, and one of the ways that I am going to show you is the prime factorization. So I'm going to do this actually with 72. So if I had to take a square root of 72, I would start by dividing by the smallest prime number. Now remember, your prime numbers are numbers like 2, 3, 5, 7, 11, and so on. So these are numbers that have exactly one factor, exactly 2 factors, 1 and itself. So if I start dividing by 2, I get 2 and 36, and maybe you recognize that's a perfect square and you go right to 6 root 2. But if not, you just keep dividing. You know that that's going to be 2 times 18. Well, and 18 is 2 times 9. And 9 can't be divided by 2, but the next prime would be 3, and it can, so 3 times 3. Once you have the prime factorization, since we're looking for a square root, we want to circle anybody who comes in pairs. Okay, and so we end up with a 2 and a 3, so they're going to come out. So 2 times 3 comes out, and then you have 1 prime left inside, which is a 2. And so that is 6 root 2, which is the same answer they got there, only they broke it down a couple different ways. So I'll practice that method, and you can then use the biggest perfect square method if you want, or you can use the prime factorization method. So let's take a look at letter A, which is 18. For that one, I'd probably just say right away I know that that's 9 times 2, so square root of 9 is 3, so 3 root 2. Well, you get to 48, and you're tempted to say 6 times 8, but neither 6 nor 8 are squares. So I might choose to do that one over here. And also, you've got this 5 in front, so we need to keep an eye on that. So I'm going to do primes. So I'm going to go 2 times 24 and 2 times 12. I'll do 2 times 6 and finally 2 times 3. So it's all broken down. Now I circle the pairs, 2 and 2. So we actually have 2 pairs of 2s, so those each have to come out. So we're going to have a 5 that's already out there. So 5 times 2 times the other 2 that comes out, and a 3 left inside. And so when we multiply on the front, we'll have 5 times 2, which is 10, times 2, which is 20. So 20 times the square root of 3. Let's do one with variables. So let's look at D. So with D, we have 24, and you don't want to use 6 and 4 or 12 and 2. You want to think about what maybe, I guess you do want to use 6 and 4. That would work. 4 is the biggest square that would go in. And I would think about y squared means you have 2 y's. So actually you circle them and you know that we're going to have a y coming out. So the square root of 4 is 2, so 2y comes out, and the square root of 6 will stay inside. So 2y root 6. If you like to factor 24, you would start with 2. So 2 and 12, 2 and 6, 2 and 3. You have a pair of 2's that came out. And then you have actually a primes inside, 2 times 3. That's why the 6 is on the inside. So let's do quick with 45. 45, I see 3 and 15. And then I see 3 and 5. Those are the primes. Now with your B's, you have 3 of them. So really, you only get to circle one pair of 3's. So a 3 and a B come out, a 5 and a B stay in. And that's how we're going to break down square roots using radicals. Now, on the next page, we're going to skip over number 3, and we're going to talk about some bigger roots. So, for example, we're going to talk a little bit about the cube roots. So the process of finding roots can be expanded to cube roots. So, for example, the cube root of 125 is 5 because 5 times 5 times 5 is 125. Now, if we had this y cubed and we were looking for a cube root, we could take out all 3 y's. And so the cube root of y cubed is just y. So we're going to practice a couple of those now. So what I'm going to do is go down to the try these B towards the bottom. Of course, there are some more examples, and so you can always read those on your own. So let's do this 24. I know we worked on it before. We said it was 2 and 12, which is 2 and 6, which is 2 and 3. Now, because it's a cube root, I'm looking for a set of 3 this time, which I now have. I have 2 coming out, and it's a cube root of 3 left over. And the same thing holds true with variables. So with 54, if I did, that's 2 and 27. Can't use 2 anymore, so I'll go to 3 and 9. And then I'll use 3 and 3, and I do have one set of 3s that will come out. And then for the z's, I actually have 3 of them, so I will circle those 3. So I have a 3z come out, okay, and then I have a cube root of 2 left inside. Let's do one more. For 40, I'm going to do a 2 and 20, then a 2 and 10, finally 2 and 5, all primes. I have 4 B's this time, so I'll have one group of 3 B's and then 1 B left over. So I've got a 2 coming out and a B coming out, so 2B. Then a cube root of, and then I have a 5 and a B left over. And then if it was a 4th root, we would just look for groups of 4, and if it was a 5th root, we would look for groups of 5. All right. Let's go on to the next page. There's a few more check their understandings up there, but I think we did enough of those. You can practice those on your own. What I'm going to go to next is kind of in the middle of the page here. There's a rule about fractional exponents, and it's not highlighted or anything, so I want to do that for you. So I'm going to go to my highlighter, and I think I can pick a different color highlighter just to change it up. Let's pick orange. So we've got a rule for looking at expressions that have exponents, but those exponents are fractions. So if you look, you'll notice that if a is to the m over n power, the m is the power of a, and the n is the root of a. So when you have a power, if you have a to any power, that's a fraction, m over n, the m is going to represent your power. That's like your exponent. And n is going to represent your root, like your radical. And so that's going to help us to rewrite these expressions so that we might be able to simplify them if we use that formula for power over root. Some of them we just are going to rewrite. So if we take a look at the try these, see 13 to the 1/4 power. So that means it's the first power of 13, but it's the 4th root. So that's just the 4th root of 13 to the first power, which is just the 4th root of 13. So again, it goes power on top, root on bottom. So you might want to remember P over R. So power is 3, so it's going to be the 5th root of 7 to the 3rd power. And the last one is going to be the, power over root, so it's going to be the square root of x cubed. However, this one can be broken down because there are actually 3 x's. And since remember that's like a square root, we can pull out one of them, one group of 2. So we'll have x come out, and we'll have x stay in. All right, so that takes us to the practice. And we will definitely spend some more time on exponent rules, especially with the extra activity practice, and then I'm going to do a little bit more with the powers and the roots as well. So please, for your assignment, if you could do the problems of 8 through 16, and you can check your work online and be ready to ask questions at our next Zoom. Have a great